Hi everyone, so in this video we're going to go over cortisol, the stimulus for cortisol, the release of other hormones to stimulate the synthesis of cortisol from cholesterol, and the effects cortisol has on a few organs within the body. So beginning with the stimulus, it's generally going to be due to a low blood sugar level. So in most instances, this is going to be with a BGL less than 4, otherwise known as hypoglycemia. In addition to this, it can also be caused with stress. So long-term stresses will also aid in the release of cortisol. So moving on down to the mechanism of action in relation to cortisol. So it all begins with corticotropin releasing hormone, now otherwise known as the CRH. And that's secreted from the hypothalamus. CRH tells or stimulates the anterior pituitary gland to then release adrenocorticotropic hormone, or otherwise known as ACTH. ACTH then enters the bloodstream and moves its way down to the adrenal glands. And in the adrenal glands, it looks for part of the gland known as the zona fasciculata. And specifically on the zona fasciculata, ACTH looks for a G-stimulatory protein, a G-protein coupled receptor, which will then stimulate second messenger systems to synthesize cortisol from cholesterol. Now the reaction looks something like this. You have GDP detaching from the 7-transmembrane receptor and binding GTP. GTP then stimulates adenyl cyclase, so an embedded enzyme, and that then stimulates protein kinase A. Now, protein kinase A then phosphorylates a process to convert cholesterol into cortisol. Now, at this point, cortisol is then moved into the bloodstream. However, it does not just do this and move through the bloodstream by itself. It uses transport proteins. One being albumin, and the other one being cortisol binding globulin, or otherwise known as CBG. Now, CBG and albumin, they carry cortisol to a few different areas. We're going to focus on 4 main organs in this video. So if we begin here at the liver, cortisol effects on the liver, they're going to be gluconeogenesis. We're also going to do glycogenolysis. The effects they have on a fat cell, or a triglyceride. Cortisol will break down the fat cell, and you will gain glycerol. Glycerol is, of course, used in the process of gluconeogenesis in the liver. We'll get back to that in a second. Glucose also will have an effect on adrenergic receptors by increasing the expression. So cortisol will modulate the expression of adrenergic receptors on tissue. So you can think of this as, adrenergic receptor on the myocardium, for example. This will increase the sensitivity to neurotransmitters such as norepinephrine. So I'll write down sensitivity, in addition to modulation. And finally, the effects it has on muscle. So cortisol acting on muscle, specifically acting on proteins, it's going to break down the protein, it's going to produce amino acids. Now glycerol and amino acids, these two are going to combine and move all the way up, and this is how you get gluconeogenesis within the liver. So this reaction, glycerol, amino acids within the liver, is gluconeogenesis. Both of these options here, they're going to promote glucose, and that increases BGL. Cool. So with this reaction on these 4 organs here, we've increased our BGL, which was the stimulus in the first place because we had decreased BGL. We were hyperglycemic. So now we've increased our BGL with the help of cortisol. And we've also increased the sensitivity tissue has to transmitters such as norepinephrine, or hormones such as norepinephrine. And this then increases our sympathetic response as well. So in short, our blood sugar has raised, our sympathetic nervous system is stimulated, and that is how cortisol works in the body.